On the morning of December 5, 1941, near the village of Krasnaya Polyana, just 19 kilometers from the Kremlin, General Feldmarschall Fedor von Bock stood beside his staff car, watching in silence as temperatures plummeted to -35°C. The vehicle wouldn't start. Neither would the Panzer III beside it, nor the lorry behind that, nor the motorcycle combination parked at the roadside. Across Army Group Center's front, stretching from Kalinin to Tula, somewhere between 40 and 60% of all German motor vehicles had frozen solid overnight. The previous day, German reconnaissance units had spotted the spires of Moscow through their field glasses. Wehrmacht commanders had been measuring distances to the Soviet capital in kilometres, not miles. The prize was so close that junior officers spoke openly of Christmas in Red Square. Yet at -35°, the much-vaunted German war machine, the mechanized force that had conquered Poland in 27 days, and France in 39, simply stopped working. This wasn't a temporary setback. This was the catastrophic failure of German materiel assumptions meeting Soviet winter reality. The paradox was brutal. German planners had anticipated the cold would cripple Soviet logistics, destroying the primitive Russian supply system and leaving Red Army units stranded without fuel, ammunition, or food. Wehrmacht intelligence estimated that Soviet lorries, largely pre-war American Ford and Gaz models operating on dirt tracks, would freeze first. German vehicles, built to exacting Teutonic engineering standards, would maintain mechanical superiority whilst their opponents collapsed. On paper, this wasn't hubris, it was probability. Yet between December 1941 and March 1942, the Wehrmacht lost more vehicles to mechanical failure than to Soviet action. The Russians kept moving. This wasn't because German engineering was inferior, quite the opposite. It was because German precision engineering was catastrophically unsuited to the very conditions Berlin had counted on to deliver victory. Standard German military doctrine in 1941 held that technical sophistication translated directly to battlefield superiority. The Wehrmacht's motorization program, centered on manufacturers like Opel, Daimler-Benz, and Büssing-Nag, had produced vehicles engineered to tolerances measured in hundredths of millimeters. Crankshafts were machined to 0.01 millimeter accuracy. Piston rings were precision ground. Engine blocks received multi-stage heat treatment to ensure uniform metal properties. At the Friedrichshafen Proving Grounds in Bavaria, test vehicles routinely operated at temperatures down to -20°C without modification. German planners looked at Soviet vehicles and saw primitive simplicity. The Gaz AA lorry, license-built from the 1930 Ford Model AA, used castings where German manufacturers employed forged components. Tolerances were loose by European standards, sometimes as much as 0.5 millimeters. Surface finishes were rough. Soviet engines rattled, they leaked oil, they smoked. Intelligence reports from the 1939 to 1940 Winter War in Finland noted that Soviet lorries required constant maintenance, broke down frequently, and were, in the assessment of one German observer, characteristic of Bolshevik industrial incompetence. What German analysts failed to understand was that Soviet incompetence was actually brutal functionality. The secret was in what Soviet engineers had deliberately designed for, not what they'd failed to achieve. The Red Army operated on the assumption that vehicles would freeze. Soviet doctrine planned for it. Russian mechanics expected it. Whilst German technical manuals assumed proper winter facilities and preheating equipment, Soviet maintenance schedules simply stated, "In temperatures below -15°, engines will not be shut down except for repairs." The Gaz AA's loose tolerances weren't manufacturing defects, they were thermal expansion allowances. At -30°, metals contract. A German engine machined to 0.01 millimeter tolerances would seize as hardened steel components shrank at different rates than cast iron blocks. The Soviet engine, with its crude 0.5 millimeters clearances, had room for metal to contract and still maintain oil film between moving parts. A captured Soviet maintenance manual, recovered near Vyazma in October 1941, explicitly noted, "Engine clearances set for -40 operation. Do not adjust to German standards." The German military used SAE 30-weight mineral oil in summer and SAE 20-weight in winter. Both specifications had been developed for European conditions, tested extensively in Germany, where winter temperatures rarely dropped below -15 degrees for extended periods. At -25 degrees Celsius, SAE 20 oil achieved the viscosity of treacle. At -30, it was effectively solid. Crankshafts couldn't turn. Even if hand-cranked to start, engines would run for perhaps 30 seconds before seizing as congealed oil failed to reach bearing surfaces. Soviet vehicles used a different solution entirely. The Red Army issued straight kerosene for winter engine oil. Not kerosene-thinned oil, straight kerosene. German intelligence officers who first captured this information in November 1941 assumed it was a temporary expedient, proof that Soviet logistics had already collapsed. They were wrong. Red Army technical bulletins from 1939 specified kerosene operation for all vehicles below -20 degrees. Kerosene provided almost no lubrication compared to proper oil, but it remained liquid to -60 degrees. Soviet engines wore out faster, perhaps 30% faster than German equivalents, but they started. They ran. Critically, they moved. German fuel presented an even more immediate problem. Wehrmacht specifications required petrol refined to high standards, low sulfur content, precise octane ratings, minimal water contamination. These specifications ensured optimal engine performance and reliability. They also ensured that at -25 degrees, any moisture in German petrol tanks would freeze, blocking fuel lines and carburetors. Water content in German military petrol was specified at less than 0.02%, a standard that required careful refining and handling. Soviet petrol, by contrast, was filthy by German standards. Water content ran as high as 2%. Sulfur and sediment levels would have failed every German quality control test. But crucially, Soviet supply sergeants added alcohol directly to fuel drums, sometimes as much as 10% ethanol by volume. The alcohol prevented water from freezing and kept fuel lines clear. It reduced engine power, increased fuel consumption, and caused long-term corrosion. But at -35 degrees on a road 50 kilometres from Moscow, a lorry that moved at 80% efficiency was infinitely more valuable than a lorry that didn't move at all. Oberst Hans-Jürgen von Arnim, commanding officer of the 17th Panzer Division, noted in his diary on December 12, 1941, "Our vehicles stand frozen whilst Russian lorries, primitive, rattling things we captured last week, drive past our positions. Russian prisoners laugh when we ask how they start their engines. They point to oil drums and say, 'Kerosene.' Our mechanics think this is sabotage advice. It isn't." German vehicles were designed to start cleanly and efficiently. The standard Opel Blitz 3-ton lorry featured an electric starter motor powered by a 12-volt battery. The battery was positioned on the exterior of the chassis, where it could be easily accessed for maintenance and replacement. This was logical engineering. Batteries are heavy, and mounting them externally simplified servicing. At -30 degrees, lead-acid batteries lost approximately 75% of their cranking capacity. The externally mounted German batteries, exposed to the full force of Russian winter air, froze solid within hours of engine shutdown. Soviet gas lorries also used 12-volt electrical systems. But Red Army doctrine assumed batteries would freeze. Soviet drivers were issued 2 batteries per vehicle. One battery remained installed in the engine compartment. The second was kept inside the cab, or more commonly inside the driver's tunic, next to his skin. When the installed battery froze, the driver would pull out the warm battery from inside his clothing, swap them over, and start the engine. Once the engine was running, the previously frozen battery would be placed near the engine to warm up, or inside the driver's tunic for the next stop. German liaison officers who observed this practice in early 1942 described it as barbaric and proof of Soviet backwardness. But the real divide wasn't in batteries, it was in the fundamental assumption about whether vehicles should be shut down at all. Wehrmacht doctrine assumed vehicles would be parked in proper motor parks with access to heated shelters or at minimum preheating equipment. The standard German vehicle preheating system consisted of external heaters that warmed engine oil before starting. These heaters burned petrol or diesel and required approximately 30 minutes to bring an engine to starting temperature. They were engineered solutions, designed by men who assumed armies fought in countries with infrastructure. Russia had no infrastructure. The Wehrmacht was fighting across territories where roads were dirt tracks, towns were collections of wooden buildings, and the only heated spaces were peasant cottages already crammed with soldiers. German preheating equipment required flat ground, wind protection, and fuel. In the open steppe at -35 degrees, in positions under artillery fire, with supply lines stretched 1,200 kilometres back to Germany, preheating equipment was worthless. The Soviet solution was magnificently simple. Don't turn the engines off. Red Army motor pools operated vehicles in shifts. Drivers would run engines continuously for 24, 48, or even 72 hours straight. When one driver's shift ended, another would take over whilst the engine continued running. They burned enormous quantities of fuel, perhaps 3 times what German logistics planning assumed, but Soviet supply officers had planned for this. Russian fuel consumption estimates for winter operations, documented in pre-war manuals, assumed engines would run continuously. Hauptmann Ernst von Hammer, a supply officer with the Fourth Army, captured this reality in a report dated 8th of January 1942. We captured a Soviet fuel dump yesterday containing perhaps 200 drums. Our intelligence estimated this represented 3 days' supply for a Soviet rifle division. By German calculations, this fuel should have supported operations for a fortnight. Now I understand the discrepancy. The Russians never shut down. Their lorries idle through the night. We calculated their fuel consumption based on movement. We should have calculated it based on time. They are burning fuel to survive, not to move. But burning fuel to survive means they can move when we cannot. German vehicle cooling systems were designed around ethylene glycol antifreeze, a sophisticated chemical compound that prevented freezing down to -40 degrees when mixed in proper proportions. Wehrmacht logistics manuals specified a 50-50 mixture of antifreeze and water for all vehicles operating in winter conditions. This was the correct technical solution, proven in extensive testing. The specification was perfect. The supply was not. Antifreeze wasn't manufactured at the front. It was produced in German chemical plants and shipped east via the same railway network that was already struggling to supply ammunition, fuel, food, and winter clothing. Each lorry required approximately 20 litres of antifreeze mixture. The Wehrmacht had approximately 600,000 motor vehicles on the Eastern Front by December 1941. That meant 12 million litres of antifreeze, plus reserves for losses to leaks, combat damage, and evaporation. The actual amount delivered by 1st December 1941 was estimated by Quartermaster General Eduard Wagner at less than 15% of requirements. German crews improvised. They drained cooling systems every night and refilled them every morning with water heated over fires. This worked when there was time and when men weren't being shelled. When it didn't work, engine blocks cracked as residual water froze and expanded. A cracked engine block was a mechanical write-off. Replacement engines had to be shipped from Germany. By January 1942, the Wehrmacht was losing more vehicles to cracked blocks than to all forms of Soviet action combined. Soviet vehicles used a different approach. They didn't use antifreeze at all. Red Army doctrine for temperatures below -20 degrees was to drain the cooling system completely and operate engines without coolant. This was technically insane by German standards. It meant engines would overheat during prolonged operation. Soviet technical manuals acknowledged this explicitly. Operation without coolant limited to 30-minute intervals. Allow 15 minutes cooling between operational periods. The Russians accepted that their vehicles would overheat, would operate inefficiently, and would wear out faster. But they would operate. To German observers, this was further proof of Soviet technical incompetence. They were destroying their own vehicles through improper operation. What the Germans failed to understand was that the Soviets were comparing different failures. A vehicle that overheated after 30 minutes could be restarted after cooling down. A vehicle with a cracked engine block was dead. The Soviet calculation was simple. Better to wear out engines through overheating than lose vehicles entirely to frozen blocks. Red Army maintenance records from the 43rd Army, captured in February 1942, showed an average engine lifespan of 8,000 kilometres in winter operations, compared to the peacetime standard of 50,000 kilometres. German records from the same period showed whole battalions of vehicles frozen immobile with perhaps 200 kilometres on their engines. German vehicles were equipped with standardized tyres manufactured to exacting specifications by Continental, Dunlop, and other major firms. These tyres used natural rubber compounds optimized for European roads, compounds that remained flexible in temperatures down to -15 degrees whilst providing excellent grip on paved surfaces. At -30 degrees, the rubber compounds crystallized. Tyres didn't just lose flexibility, they shattered. A vehicle hitting a modest pothole at -35 degrees might lose 1, 2, or all 4 tyres in a single impact as the crystallized rubber fractured like glass. The 7th Panzer Division's War Diary entry for December 15, 1941, recorded, "Morning temperature -38 degrees, attempted to move supply column to forward positions. Of 42 lorries that departed the assembly area, 31 suffered tyre failures within the first 5 kilometres. Remaining vehicles recalled. Operation cancelled." German tyre supply chains couldn't cope with these losses. Tyre production was already strained, supporting operations across Europe and North Africa. The Eastern Front was consuming tyres faster than Germany could manufacture them. Soviet vehicles had the same problem. Their tyres shattered too. But Soviet logistics had planned for this. Pre-war Soviet doctrine for winter operations specified that wheeled vehicles would be fitted with chain overpacks that wrapped the entire tyre and wheel assembly. These chains didn't prevent tyre failure, but they did allow a vehicle to continue operating after tyre failure. A Soviet lorry with 4 blown tyres, running on chain overpacks, could still move at perhaps 15 kilometers per hour. It was slow, inefficient, and destroyed the wheels. But it moved. A German lorry with blown tyres couldn't move at all. The situation with tracked vehicles was even worse. German tanks and armoured vehicles used track designs optimized for paved roads and firm ground. Track pins were hardened steel, machined to close tolerances. At -30 degrees, these hardened pins became brittle. Track sections would snap under normal operating loads. The Panzer III, the Wehrmacht's standard medium tank in 1941, suffered catastrophic track failure rates in December 1941. A study by the 3rd Panzer Group's technical officer, dated 28 December 1941, reported that, of 156 Panzer III vehicles in the group, 89 are immobile due to track failures. Most failures occurred during normal movement, not combat. Tracks simply fracture. Soviet tanks used softer steel for track components. This was, by German standards, a sign of inferior metallurgy. Soft track pins would wear out faster and were more prone to deformation under combat loads. But soft steel doesn't shatter at -30 degrees. It bends. A bent track pin could be hammered back into shape by a crew with a sledgehammer. A fractured German track pin required a replacement, which meant either cannibalization from another vehicle or a part shipped from Germany. The Battle of Moscow, which formally began on October 2, 1941, and concluded on January 7, 1942, provided the definitive proof that German assumptions about cold weather logistics were catastrophically wrong. During the first phase of the offensive, from October through early November, German forces advanced steadily despite muddy conditions. Army Group Center's supply system, whilst strained, continued to function. German vehicles operated, if not optimally, then adequately. The temperature shift came rapidly. On November 6, 1941, forward units of the 4th Panzer Group reported temperatures of -8 degrees Celsius, cold but manageable. On November 7th, -15. On November 13th, -22. On December 4th, -35. On December 7th, -38. Each temperature drop revealed new mechanical failures. First batteries, then oil, then fuel lines, then tires, then tracks, then engine blocks. The Soviet counteroffensive, launched on December 5, 1941, wasn't just a tactical operation, it was a logistical demonstration. Whilst German forces struggled to start vehicles that had been immobile for hours, Soviet divisions were conducting tactical movements of up to 40 kilometres per day. The 16th Army, commanded by Lieutenant General Konstantin Rokossovsky, advanced 80 kilometres in 4 days, whilst temperatures remained below -30. German intelligence officers couldn't explain it. The Russians were supposed to be frozen immobile, their primitive logistics system was supposed to have collapsed. But Soviet logistics hadn't collapsed because Soviet logistics had been designed for exactly these conditions. A post-war analysis by German General Major Burkhard Müller-Hillebrand, who served as head of the Army General Staff's organizational branch, concluded, "We planned for a short war in Russia, to be concluded before winter. When winter came, we discovered that our vehicles, our fuel, our oil, our entire supply system had been optimized for European conditions. The Russians had planned for winter from the start. Their vehicles were crude, but they were crude in ways that made them functional in cold we had never adequately considered. We assumed our technical superiority would overcome environmental factors. We were wrong. German vehicle losses during the winter of 1941 to 1942 tell the story with brutal clarity. Between 1st December 1941 and 31st March 1942, the Wehrmacht lost approximately 180,000 motor vehicles on the Eastern Front. Of these, Soviet action, including air attack, artillery and direct combat, accounted for approximately 35,000 vehicles, or 19%. Mechanical failure, much of it cold-related, accounted for 145,000 vehicles, or 81%. The breakdown by failure type is even more revealing. Cracked engine blocks, 47,000 vehicles. Track failures, 23,000 vehicles. Tire failures preventing movement, 31,000 vehicles. Seized engines due to oil failure, 19,000 vehicles. Electrical system failures, primarily frozen batteries, 16,000 vehicles. Frozen fuel systems, 9,000 vehicles. These weren't battle losses. They were engineering failures, failures of vehicles built to excellent standards for the wrong environment. Soviet losses during the same period were also significant. The Red Army lost approximately 95,000 motor vehicles between December 1941 and March 1942. But the causes were reversed. 61% to enemy action, 39% to mechanical failure. Soviet vehicles were being destroyed by German fire, not by cold. The Russians were moving, fighting, and dying. The Germans were freezing in place. The operational impact was decisive. By January 1, 1942, Army Group Center had approximately 35% of its authorized motor vehicle strength operational. The remaining 65% were either destroyed, abandoned, or frozen. Soviet forces facing Army Group Center had approximately 71% of authorized vehicle strength operational. In a war of movement, the side that can move wins. The side that freezes in place loses. The German failure in Russian winter wasn't a failure of engineering quality. It was a failure of engineering assumptions. German vehicles were superbly engineered for the conditions German engineers expected them to face. Close tolerances, hardened components, sophisticated electrical systems, and standardized specifications all made perfect sense for armies operating in Europe with access to infrastructure, supply chains, and industrial support. Soviet vehicles were engineered for the conditions Soviet engineers knew they would face. Loose tolerances allowed for thermal expansion. Soft metal components could be field repaired with basic tools. Simple electrical systems could be maintained by conscripts with minimal training. The entire design philosophy assumed absence of infrastructure, extended supply lines, and extreme environmental conditions. This wasn't a choice between good engineering and bad engineering. It was a choice between two different engineering philosophies, each optimized for different conditions. German engineering optimized for performance, for getting the maximum capability from each vehicle under controlled conditions. Soviet engineering optimized for survival, for keeping the maximum number of vehicles operational under chaotic conditions. The bitter irony was that German planners had explicitly counted on cold weather to cripple Soviet logistics. Wehrmacht intelligence assessments from August 1941 predicted that Russian winter would severely restrict Red Army mobility, whilst German mechanized forces, properly equipped and maintained, will retain operational capability. The assessment was correct about the restriction on mobility. It was simply backwards about who would be restricted. German forces did eventually adapt. By the winter of 1942 to 1943, Wehrmacht units on the Eastern Front had adopted numerous Soviet practices. Vehicle engines ran continuously. Kerosene replaced oil in extreme cold. Cooling systems were drained rather than relying on antifreeze. Crews kept batteries inside their clothing. These were all expedients that German engineers would have rejected as barbaric 2 years earlier. But they worked. The fundamental lesson, however, was never fully absorbed. German industry continued to produce vehicles optimized for European conditions throughout the war. Design tolerances remained tight. Components remained hardened. The engineering excellence that made German vehicles superior on French roads continued to make them fragile on Russian steppes. Soviet vehicles remained crude by German standards and remained operational in conditions that froze German equipment solid. A post-war interview with Soviet Marshal Georgy Zhukov captured the strategic reality. The Germans came to Russia with the finest equipment in Europe. They assumed this meant they had the finest equipment for Russia. They were wrong. Russia does not care about engineering excellence measured in hundredths of millimeters. Russia cares whether your vehicle starts at -40 degrees, whether it moves after your tires shatter, whether it continues operating when there is no antifreeze, no heated shelters, no infrastructure. The Germans built vehicles for Germany. We built vehicles for Russia. In Russia, our vehicles won. The Nazi assumption that cold would kill Soviet logistics proved correct in only one respect. Cold was indeed a decisive factor in Eastern Front logistics. They were simply, catastrophically, wrong about which side it would kill. German vehicles, built to standards that would have impressed any European military engineer, froze solid whilst Soviet vehicles, derided as primitive, crude, and backwards, kept moving. Precision engineering had met Russian winter. Russian winter won. The lesson was simple, brutal, and paid for in the frozen corpses of 180,000 German vehicles. In warfare, the best solution isn't always the most sophisticated one. Sometimes the best solution is the one that works when nothing else does. The Germans learned this lesson at -38 degrees, 19 kilometres from Moscow, whilst Soviet lorries drove past their frozen positions. By then it was far too late.